All right, here we go. Fourth and final FRQ. Good one here. It's a real-world question. Remember, though, it is a non-calculator. So take your calculator. Can't use it. All right, here we go. Let's go to start with the prompt. The rate of fuel consumption in gallons per minute recorded during an airline flight is given by a twice differentiable and strictly increasing function R of time t. It's a really wordy prompt. Let's break that down. The rate is given by function R. So let's label that as a rate. What else? That's also in gallons per minute, so definitely a rate. It's twice differentiable. Twice differentiable, that's just telling me that the second derivative exists. Good to know. Then it's strictly increasing. I wonder why they're telling me it's strictly increasing. All right, let's move to the second sentence. The graph of R and a table of selected values of R of t for the time interval 0 to 90 minutes are shown above, or to the right here. So I have a graph, I have R of t. These are the exact same thing. Just two different ways to look at it. Use the data from the table to find an approximation for R prime of 45. Show the computation that led to your answer. Indicate units of measure. So I want to use the table. I want to approximate R prime of 5. Well, I have R of t here. So I know R prime of 45. I know R prime of 45, that is the slope at 45, but I only have certain values. And I'm trying to approximate that. So I'm going to use the average rate of change to approximate that. That'll be pretty close, but not exact. That'll be pretty close. R prime of 45. 45 is the t value. That is between 40 and 50. So if I find the slope between here, it's going to be pretty close to the derivative, but not exact. That's why it's a approximation. So let's find out what that is. R of 50, that's going to be 55 minus 40 over 50 minus 40. 50 minus 40. Great. So I have that here. Let's solve that. I get 15 in the numerator, and I get 10 in the denominator, so that equals 1.5. Did I answer the whole question? Indicate units of measure. Well, the numerator was gallons per minute divided by 50 minus 40, that's minutes. So this comes out to be 1.5 gallons per minute squared. That's my approximation for R prime of 45. Let's go to part B. The rate of fuel consumption is increasing fastest at time t equals 5. What is the value of R prime of 45? Explain your reasoning. The rate of fuel consumption, okay, that's R, is increasing fastest at time t equals 5. So if I'm increasing the fastest, that means whatever the derivative of this is at a maximum. So another way of thinking increasing the fastest, that is whatever the derivative of this is at a maximum. So this we can interpret as R prime of t is at a max. Well, if R prime of t is at a max, then R double prime of t would be changing from positive to negative. So let's see if we can figure out how that helps us. Well, if R prime of t had a max, it would look like this. It would look like this. So this is R prime of t. Well, I know this, that at that point its derivative, R double prime of t, is 0. So the value of R double prime of 45 is 0 because R prime of 45 will be a maximum, and therefore its slope, R double prime of 45, must be 0. All right, see you in the next video for parts C and D.